Today we're going to talk about graphing a system of equations. A system of equations are two or more equations that are graphed on the same coordinate plane. When you graph a system of equations, you can find solutions, and a solution to a system of equations is any ordered pair that satisfies both equations, or ordered pairs that are part of both lines. When looking at systems of equations, there can be three different kinds of solutions. The first thing you could see is a pair of intersecting lines. Intersecting lines have one solution because there's only one point that both of these lines have in common. In addition to being asked how many solutions there are, if there is one solution to a system of equations, you'll be asked to name the solution. And the name of the solution is the ordered pair that the two lines have in common. So in this case, the solution would be 1, -1. Another kind of system of equations you could see has an infinite number of solutions. In order to have an infinite number of solutions, you need to have two equations that graph the exact same line. So if you look at this problem, we have two equations down here, and both of these equations are this exact line. We say that they have an infinite number of solutions because every ordered pair that lies on this line would be considered a solution because it's part of both lines. So when you have two lines, one on top of the other, we call those coinciding lines, and coinciding lines have an infinite number of solutions. The last type of system of equations that you'll see are parallel lines. Parallel lines have no solutions, and the reason parallel lines have no solutions is because there are no ordered pairs that are part of both lines. Okay, parallel lines never cross, so they're never going to have any ordered pairs in common. In addition to being able to recognize the number of solutions you have, you may be asked to create a graph to determine the number of solutions there are. In order to do this, the easiest way to graph a line is to put it into slope-intercept form. When you do this, you can look at the equation and use your slope and your y-intercept to help you create a graph. In this case, we're going to start at our y-intercept, which is -2, and we're going to put a dot on our graph at -2. Then we're going to use our slope to help us out. Our slope is 3, which if we think of that in terms of rise over run, it means we have a rise of 3 and a run of 1. So from this starting point, we're going to go up 3 places and to the right 1. We're going to rise 3 and run 1. And I'm going to keep putting on some points in order to help me make a line so that I can make it nice and straight and see where this all fits together. So I'm going to connect those dots using a straight edge. And now I'm ready to graph my second line. So the second line that I have here is not in slope-intercept form. So the first thing I'm going to want to do is put that equation into slope-intercept form. To do that, I need to get y all by itself. So I'm going to subtract x from both sides and move the y, get the y all by itself. Then I need to divide everything by -2. Because again, I don't want just y, I don't want just 2y, I want y all by itself. So when I do this, I get 1/2 x plus 3. So now it's time for me to use my slope and intercept in order to graph this. I see that my y-intercept is +3, so I'm going to use that as my starting point. And I have a slope of 1/2. Slope of 1/2 means I have a rise of 1 and a run of 2. So from the starting point, I'm going to rise 1 and run 2. And I'm going to put a bunch of different points on here so that I can graph this line pretty easily. I'm going to use a straight edge to connect these dots together. There we go. And now, looking at the system of equations, I can see that I have one solution because my lines intersect. My one solution is this point right here. So, in answer to the question, I have one solution, and the solution is at the ordered pair 2, 4.